We have formulas for sine and for cosine, but we don't have a formula for tan. And we don't know where to start. But a good place to start is like, well, what do we know about? Like if I wanted to come up with a formula for tan. So this is really interesting because for this derivation or this proof, you can basically, you right now, believe me when I say this, can basically do the whole thing all by yourself. Except you need help with one step. So I'm going to help you with that one step. And then you might need to push in the right direction for another part. But for the most part, like with one little tip, you can do this whole thing all on your own. Believe me. Okay. So how would we get started? Like if you needed a diagram for cosine. We did all that prep work for sine yesterday when we did sine. What would I do for tan? I see a bunch of hands. That's good. Adam, what do you think?
You could do tan AB equal to sine AB over cos AB.
Yeah, we know that tan is sine over cos. Is that what other people were thinking? That tan is sine over cos? Why is that a good thing? I mean, when we do identities, we change everything to sine and cos. That tends to work. It's similar why we would do that in this case. But really, it's because we know something about sine and cosine. So why not take advantage of that? So go ahead and do that. If you're not quite sure what we mean, tan of x is sine x over cos x. So tan of a plus b is... I hope we got this, sine of a plus b over cos of a plus b. Right? That's something that a lot of us could come up with on our own. That's a good start. Now, what would be our next step? Sorry? Nice. Use the formulas that we've already learned. That's kind of the idea. Very good. So do that. This is a good little test that you have memorized the formulas. Who knows the formulas? How many people are pretty I know I got these down. You don't actually have to put your hand up, but some of us probably have them nailed, and some of us are still maybe, I'm still learning them. I kind of mix them up sometimes. You really gotta just work with them and practice a little bit to get them. Okay, so I've done this part. Sine A cos B plus cos A sine B. So we notice that for sine, it shares the same sign, A plus B, and we're adding. But cos of A plus B, we're subtracting, right? So we got that. I saw some people trying to do the next step. This is a step that you need help on. This is a step that if somebody figured this out on their own, I would be very impressed. I would be pretty blown away. So this is a step you need help with. You can't cancel things out here. Don't think that, because we're adding. We're still adding. I've got something plus something, so you can't start crossing things out on the top and the bottom, right? We can't do that. If I gave this to you more as an identity, like if I gave you the formula, maybe if you were really in the right headspace and really creative, you'd be able to figure out what to do next. Because in hindsight, you can kind of go, okay, yeah, I see why that would make sense. But to be honest, the next step is really hard, so I'm just going to give it to you. We're going to multiply by something which is 1 over cos A cos B all over 1 over cos A cos B. So now I want you to take over, and you could, pretty much, just try it. Give it a try. You could pretty much do every step from here, although there's kind of 2 ways you could go in the first step, so you got to go the right way, but I want you to give it a try and see how far you can take this.
There's a reason.
1 over.
No, I did that before, so then I was trying to figure it out.
Why is it 1? Why is it 1? Because me and Adam were thinking times talking about it, could say this plus.
Yes, it doesn't usually do it because you have to say so that's a good idea. And not usually when there's like 2 things. This is the top, right? And you can split it to this over this. Now it's this. Bottom. You probably want to do all 4.
It's kind of big mess. Don't try to like simplify as you go.
Don't try to simplify.
On the first step. Afterwards, you're going to obviously simplify.
Oh wait, Adam, so I don't think we're supposed to cancel these out. You said not to simplify.
So I'm going to give you one more little push. This is the other place where if people start going down, not quite the wrong road, but you do have to kind of do it the right way. And you might ask yourself, well, how would we know how to do that? Okay, so watch. You want to make sure that you're distributing this thing we're multiplying into both. So I should get like sine A cos B over cos A cos B. This is just the top. It's kind of a mess, but it's just the top. Cos A sine B over cos. Oh, I did a nice little trick this morning of color coding. I'll do the same thing. Cos A cos B cos A cos B. Yeah, you want to split them up because if I leave the plus together, I'm not going to be able to do anything, right? And that's just the top, all over. Okay, again, continue. Try to do the same on the bottom, and then see where that gets you.
Because again, like when I have a sum in a fraction, now look at this fraction. It's all multiplying and dividing. You can start to like.
Oh yeah, baby.
All right, let's see what we have here. Okay, so this is my step from here down after I've multiplied through by that thing that I would have to give you the first time you ever saw this proof. What can I do now? Even if you didn't quite get this far, take a look up here, see what we have. I'll zoom in. What can I do? Yeah, Roberto.
On the top, you can factor out cos B and cos B, and then.
Okay, hold on. So you see a cos B and a on top and a cos B on bottom. That's why it's useful not to have a sum in the fraction. Because if I had a sum in the fraction, I couldn't do that. People try to do that, and I keep saying, no, we can't do that. Right? Good. What else can I do? Abdul?
You can do the same for the other side, if cos A cos.
Okay. Very good. And the last one, Isaac?
Cos A, cos B, and cos A, cos B.
So this whole thing can be divided, and sometimes people do that part, but then write the next part wrong. So what does that leave me with? 1. Okay, and here you might see what to do, but if you didn't, and you were doing an identity or doing a proof of some kind, and you didn't see it, it's a really good idea, because we've crossed out a lot of things. Let's rewrite what's left. Okay, so even if you know what the next step is, please don't shout it out, so let everybody kind of see if they can see it themselves. So I've got sine A over cos A plus sine B over cos B all over, we got that 1 minus sine A sine B all over cos A cos B. So again, please don't shout anything out here because I want everybody to have a chance to think about this. What do you see going on here? And if you're not seeing it yet, remember what I talked about this the other day. Don't just sit there and wait for somebody else to do it. You can do it. Like practicing thinking about hard things will make you better at thinking about hard things. So push yourself and try. Don't sit there with a fixed mindset and say, oh, not me, I can't do this. Try it. I'm going to give you a hint. What did we start with? Max, what did we start with? Tan. Don't forget, we started with tan. So now what could I do? Whoa, that's sine A over cos A. What is that? Tan A. So let's do it. Oh, and the one other thing, take a look before we go. Can't I do this? Can I get rid of that and go over times over? Right? Like everything was being multiplied together. So I can split that into 2 fractions. And I can split it into 2 fractions however I want, right? But I want it like this, sine A, cos A, sine B, cos B. So notice what those are now. You might not have noticed when it was all written as 1 fraction, but I can split it up. So sine A over cos A is tan A. Sine B over cos B is tan of B. Very good. over 1 minus sine A over cos A tan A again. And sine B over cos B tan B. So tan A plus tan B over 1 minus tan A times tan B. And that looks to me a heck of a lot like a formula. Why is this a good formula? Well, it's relatively simple compared to leaving it in all sines and cosines. I mean, remember what we end up doing. We end up actually evaluating these. By switching these back to tans, I've got a lot fewer things to evaluate. But also, the whole point of this is instead of a compound angle, A plus B, that I can't do, like pi by 12, I can't evaluate that. But I can evaluate tan of A. And I can evaluate tan of B. So now I've got, on the right side, I've got things that I'm able to do to help me with something that previously I wasn't able to do. Okay, so, just to go back, now that you see that there's this 1 in there, you could remember going back up to this first step right here, I have to multiply by 1 over this to get that 1. Right? If you wrote this step out correctly, it's 1 over cos A cos B over 1 over cos A cos B. That gets me my 1. So if you knew that it was a 1 in that position, it would make it a lot easier to remember that this is what you multiply by. How would you have figured that out on your own? You wouldn't. Right? Like, just coming up with that would be really difficult.
So I think this class yesterday we were to show like how to derive the equations at all during like the test.
It's possible, but we always give you a heads up ahead of time, and it's not on the quiz on Friday. We often do ask for that, but here's the other one, tan of A minus B, if you want to write it down. And while you're doing it, again, remember I said there's lots of these formulas, and you got to memorize them all. So we're adding 2 more today, 5 more on Thursday. And so how do you remember it? Because they're both similar, but I guess I always think like tan A plus B, you're adding on the top, subtracting on the bottom, and A minus B, you're subtracting on top, adding on the bottom, right? Like it shares the sign on top and opposite sign on bottom, I don't know. Once you practice and use it a few times, memorizing a formula is not the hardest part of a course like this. I think I mentioned this. In grade 9, memorizing formulas was tricky maybe, but not anymore.
What's the hardest part of this course?
I could memorize formulas all day. For me or for you? It's different for everybody. Trig equations that we're doing next week can be very challenging. And then we do some work with logarithms later in the course that they're not that hard, but some people don't practice because they're burned out and they're working on other stuff, and then they kind of find them hard at that point. And some people struggle with curve sketching because it's a lot of work. That wasn't a very good answer, but really it's different for everybody. Okay, so let's try this. Now the nice thing, here we go. The bulk of these questions, tan questions, is very similar to the sine and the cosine that we've been doing, where I take my pi by 12s and I break them up into angles that I know how to solve. And that part is identical to what we've already been doing. So again, to me, that's like the first step is knowing how to turn pi by 12 into something plus something correctly. If you missed a couple of days last week and you're still trying to figure this out, I would break it down into 3 steps, and that's the first one. Second one is you got to know the formula and write it down correctly. And then the third one is just replacing the values and simplifying correctly. So and the simplifying for tan is just a little different from the simplifying for the other ones because the formula is a bit different. Did everybody get that down okay? I would like to one more time go back over this list because this is what I was talking about. This is like step 1. What are the 3 values that I know that I can find? Don't worry, I'll do it. Pi by 6, pi by 4, and pi by 3. So those are, I'm breaking up everything into multiples of those, but I want to rewrite them in terms of pi by 12s. So I get 2 pi by 12. I get 3 pi by 12, and I get 4 pi by 12. I mean, you do have to be able to convert back and forth like this fairly easily, right? That is something you have to be able to do. And then multiples of this, and the most useful ones. So listen carefully. If you're still trying to figure this out, you just need to memorize this list. Like, you need to know that these are the ones we use, right? You have to get used to the idea that these are the numbers that will work. Maybe 14 pi by 12, maybe 15, maybe 16, maybe 20 here or there could be useful. I don't know. But these are to me, those are the main 6. Once in a while, another one could be useful. Okay? Don't use pi by 2. Don't use pi, 3 pi by 2, 2 pi, or any multiples of those. It will not work. Okay, so I can break up tan of pi by 12 into tan. Which one do I want? I'm going to use a specific one because there's 2 ways we're going to do it here. So you do whichever. You go ahead and do this. You don't need me for this. You can try to do this part. I'm going to use a particular one. And if you use the same as me, good. If you use the other one, good. Some of us will do it one way. Some of us will do it the other. That's fine.
So go ahead and do this.
Okay, so I've said this lots of times, but remember, this is like, I worry that some people try to skip this step and then they get stuck. And I really like showing both these steps, especially when I'm learning, because 3 minus 2 gives you the 1. Like, this is what you're trying to get. This is what you're going to do first. Then reduce. If you're looking for a step-by-step method, this is what you do. You take that red list that we had, you figure out this. 3 minus 2 is 1. You reduce, and then you use the equation. So that's step 1 done right there. So now let's use the equation. How many people used pi by 6? How many people didn't? They used pi by 3. Okay, a few. Yeah. The pi by 6 is a little bit harder. If you can avoid pi by 6s, it saves you a step later on. If you have the choice. The other reason tan's a little bit, not harder, but different is because we haven't done quite as much work with tan. And, oops. Is that what you're going to say? We haven't done quite as much work with tan, and so we're maybe not quite as quick at evaluating these. Tan of pi by 4? Isaac. 1 over 1, so 1, very good. Tan of pi by 6? No. Yeah, 1 over root 3. And that's why it's a little bit tricky, because I get fractions and fractions. And then 1 plus tan of pi by 4 is 1. Tan of pi by 6 is 1 over root 3. So you're either going to get 1 1 over root 3 or root 3 over 1. And if you can avoid the more fractions, then that's good, because once I get here, now I have to simplify the fractions. Okay? But it's actually not that bad. I'll show it to you in 2 steps. But you could actually kind of do it in just 1 extra step. Once you've done it a few times, it always works out the same. So what I'm going to do is I'm going to take these 1s and I'm going to turn them into root 3 over root 3. Just to get a common denominator. And that's what you do every time. Oh, so same thing with this one. Root 3 over root 3 plus, and 1 times 1 over root 3 is just 1 over root 3, right? And then I do this. Root 3 minus 1 all over root 3, all over root 3 plus 1 over root 3. There's a step here where you would flip and multiply. I'm going to skip it. I'll show it to you, but I'm actually going to skip it. What would it look like? It would look like this. Root 3 minus 1 over root 3. You can do it if you want. So I'm dividing fractions, so I flip and multiply. Times root 3 over root 3 plus 1. And these guys cancel, right? But once you've done this a bunch of times, you're like, okay, I know they're gonna cancel because they're both in the denominator, so they're gonna, right? Like if you can see that, you don't have to show that extra step. I say skip it. And you get root 3 minus 1 over root 3 plus 1. Is that what the other people got who did it? Nice. See, so exact same answer, but your way saved that whole mess of fractions and fractions. If you can skip pi by 6s and use pi by 3s instead, you'll save yourself a little bit of trouble. But you can't. You might not always be able to do that. So, any questions? Yes.
Are we allowed to, in the final answer, are we allowed to have fractions over fractions? Or?
No, I want it to look like this. Okay, let's try one more.
You have to know if 10 is already.
Adam, what was your question? I know you weren't really asking me, but what did you say?
Could I just do negative 12 by 3 plus, like, kind of like negative 12 by 3 plus negative 12.
So tan of negative 4 pi by 12 minus 3 pi by 12. So this will work. I think I've talked about this before, but this will work. But the problem is, down the road, I'm going to end up with a tan of negative pi by 3 that I'm going to have to evaluate. And this is something we haven't done. We touched on it when we did the negative pi to pi stuff, but you have never, as far as I know, actually evaluated a negative angle like this before. So my warning is, don't do it. If you are doing it, you have to make sure you're communicating your thinking, and you got to make sure you know what you're doing. Because I've talked to a couple of people who just think it's, oh, so it's just the negative. And I say, whoa, 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 whoa. That's not how negative angles work. So that's not what you do. Okay? So I would not recommend doing it that way. I think there's a much easier way. As you can see over here, I just did 3 minus 10. And then I end up with negative 7. Yeah, I'm stuck with the pi by 6, and in some cases you might be, but that's it. Isaac?
Okay. Is tan an even symmetry or no?
Odd.
It is odd? So why can't you just do negative tan?
So if you're using even and odd symmetry is one of the ways that you could evaluate this, but you got to be careful. You got to make sure you're doing it correctly, and you have to communicate that that's what you've done. Because tan is an odd function, this is equal to this or something like that.
Okay. You have to say you did that.
You would have to, I would want you to state that, yeah.
So just like in a little therefore statement.
Sure.
The line.
Since tan is an odd function, something like that.
Tan negative theta pi, or sorry, tan pi negative pi by.
Okay, let's talk about it specific after, but even an odd symmetry is kind of one of the ways you could do it. You could also do it about thinking about what a negative angle is, but again, it's not a strong recommendation.
So negative angle, does that mean that we're going to the other way?
Yeah.
Odd, yeah, odd is negative.
Tan of 5, remember, when you get a 5 pi by 6, you're thinking about quadrants.
Even.
So this is quadrant 2, and pi by 6 is 1 over root 3, so it's minus 1 over root 3 over 1 plus tan of pi by 4, which is 1, times negative 1 over root 3. Even an odd symmetry works, but be careful. The other real answer is whether you're talking about a positive angle or a negative angle. The result being positive or negative has everything to do with what quadrant you end up in. So a positive angle rotates this way. A negative angle just rotates the other way, but still ends up in a quadrant. Whichever quadrant you end up in tells you whether it's positive or negative. So this is 1 plus 1 over root 3 over 1 minus 1 over root 3. And then I would show this step. So this is, whoops, what happened there? So this is root 3 over root 3 plus 1 over root 3 over root 3 over root 3. Turning my 1s into common denominators, whoops, minus 1 over root 3. And then I already see that they're going to cancel. Like I only really have to show one step here. And I end up with root 3 plus 1 over root 3 minus 1. Any other questions?